Hey folks, Rusty with Sagacity All-Stream Fabrication here, and another episode in our Basic Tech series. Today we're going to talk a little bit about relief valves. You know, relief valves are oftentimes misunderstood, but they're used all the way across industry as the safety mechanism used to protect piping systems. Safety relief valves are vital and are covered across several ASME standards, API and AGA as well. I'm not as well versed in this as I should be, so we're going to bring Trey Richard with Laser Valve in for his help in this presentation. Take it away, Trey.
Thanks so much, Rusty. It's a pleasure to be here. Pressure relief valves came into prominence in the Industrial Revolution for use on steam boilers. Early models of safety relief valves looked similar to lever arms holding weights covering openings on boilers. And once the pressure in the boiler exceeded the weight carried by the lever arm, the valve would open. Over time, an entire industry was created from this, which leads us to today, where there are many sizes and many types of relief valves. Today I'm going to talk to you about two of the most prominent types: direct spring operated valves and pilot operated valves. Let's talk about what is a pressure relief valve. Pressure relief valve is a generic term used across multiple industries just to define a valve that retains pressure and relieves it. A relief valve is a PRV that is actuated by static pressure that opens proportionally and is used mainly on liquids. A safety valve is also a valve that's actuated by static pressure, but it's used with a rapid opening or pop opening, and it's commonly used on compressible media like gas, vapor, and steam. A safety relief valve can operate as both. It can modulately or proportionally open on liquids, and it can also pop or rapidly open on compressible media like steam, vapor, and gas. Set pressure is the value of static pressure at the inlet of the valve in which the valve operates. Set pressure has many names. You'll come across names like pop pressure, crack pressure, opening pressure, begin to discharge pressure. Set pressure is determined by ASME code, which is the governing authority for all pressure vessels, but also is determined by the service in which it's being used. There's another term that I need to define, but we'll get to that later. Let's get into the mechanics of the valves. We'll start here with the conventional direct spring operated valves. From the outside of this valve, you can see that there are three major parts of the body of this valve. You have the cap, you have the bonnet, and you have the body. I'll turn it around so you can see the cutout. From top down, we have the cap, which is removable and houses the set screw, and it allows the manufacturer or VR technician to set or change the set pressure of the valve. It is very important that I reiterate that only National Board certified VR or valve repair technicians are qualified to cut the wire that is usually in place from the cap to the bonnet, and it acts as a seal. This is the only way that a valve can be repaired or have its set pressure changed and retain its warranty. Now, as the owner of this valve, you may change the set pressure yourself, but please be aware that you will effectively be voiding any warranty that a manufacturer will acknowledge in regards to that valve. Now, this brings us to the second section of the valve, which is the bonnet, which houses the spring and the majority of the spindle, which is that spine that you can see running the length of the valve. This is where the compression that allows for adjustable pressure retention happens. The set screw, which we mentioned in the cap section, is turned with the screw threads to lower the top spring plate. As the pressure from the screw presses on the top plate of this spring, it is effectively transferring the K value, or the spring compressibility, to the spindle, that spine, which takes that force and transfers it directly to the disc of the valve. The seat, which is now holding all of the pressure from the spring value, is now pressing up on the nozzle, and this is where the proverbial rubber meets the road. This is what seals the pressure into the system. As this valve is sitting onto your tank or your vessel or your piping, this area here known as the nozzle is in constant contact with your media. And your media is only held at bay by the force that this spring generates and presses down upon this seat. So here's how the valve operates. Pressure is introduced at the inlet through the nozzle. Pressure is met by a greater force generated by the spring acting on the valve disc via the spindle. There is a range of pressures attributed to the compression values of the spring. They are different for every manufacturer, and manufacturers have hundreds of spring offerings that are all dependent on the set pressure required. Once the pressure of the system overcomes the force generated by the spring, or the set pressure, the result is lift. Per code, all valves must meet full lift or full open within 10% of the set pressure, 3% of set pressure in boiler or fired vessel applications. Once overpressure is relieved, the valve has a 7% blowdown allowance. And blowdown is a percent of set pressure used to express the difference between the set pressure and the reseating or reclosing pressure. So the definition I mentioned earlier that I needed to relay to you guys is called back pressure. And back pressure is a pressure that exists at the outlet of the PRV as a result of the pressure in the discharge system. It is the sum of the superimposed pressure, which is static pressure at the outlet of the PRV at the time the valve is required to operate, and the built-up pressure, which develops as a result of lift and relieving of the system pressure. If the built-up back pressure is less than or equal to 15% of the set pressure, then no action is required. But if the built-up back pressure exceeds 15% of the set pressure or is identified as superimposed, then you will find most, if not all, PRV manufacturers recommending a back pressure compensating bellows. CDTP, or cold differential test pressure correction, is an option in some cases where back pressure is constant, but that's a video for another time. The installation of a balanced bellows, which is this, it compensates the force of back pressure and it redirects it in the closing position. So as you can see here in the model, this looks like a spring, but it's actually a bellows. It is used to protect against the upward forces that could help in assisting the valve to open. Remember, this valve is designed to stay closed. And there are limits to the back pressure in which this valve can endure. 50% in this particular valve, which is designed per API 526, 35% in others. If there is more back pressure than these limits mentioned, it may be time to entertain a different valve that is somewhat back pressure resistant. Not totally resistant, but pretty close. So here we have a pilot operated safety relief valve, which consists of the body, the top plate, and the pilot control. The pilot control is the brains of its operation, and the main valve responds to what the pilot tells it. This is what operation looks like. You mount this valve onto your tank or your piping or whatever system you're going to protect. System pressure is introduced into the inlet of the valve. This sense line that you can see, the little silver part sticking out, this sense line picks up the pressure and routes some of it through the pilot control and on into the dome of the valve. There's a filter here that helps filter out debris, because due to the small orifices and smaller areas, the system needs to be very clean to use a pilot operated valve. The same system pressure that is acting here on the disc of the valve is routed and into the dome, which is the exact same system pressure that is existing right here at the dome. The surface area in which the pressure can act upon is called the piston. And this piston has a greater surface area than that of the disc. In that case, we can use the formula force equals pressure times area. We have a greater force acting downward on the piston than we do acting upward on the disc. Because of this formula, as the system pressure rises, the valve actually gets tighter. That's where the pilot valve comes into play, because otherwise this valve wouldn't open. As the system pressure rises, The pressure overcomes the force of the spring and causes the pilot to actuate. As you can see, it looks very similar to this direct spring valve. We have a set screw and we have a spring acting down on a seat. This is where you set your set pressure and you determine at what point this valve needs to operate. Once this dome vents, the system pressure can then drive up this disc piston assembly, and therefore we have lift. There are two ways lift can happen in this valve. Rapid action, or pop, which is commonly used with compressible media like gas, steam, and vapor, where this valve slams into full open and fully relieves your entire system pressure. Or it can modulate open, which is sort of like a proportional opening, where it relieves what is needed as it is needed. As far as back pressure is concerned, the reason why I said this valve is close but not 100% inherently safe against back pressure is because of its design. This pilot operated valve is safe up to 70% back pressure when we express that in terms of set pressure. The reason for this is the design of the piston and seat. There is really no surface area for the back pressure to act upon to help lift the valve. Again, these valves are to remain closed unless in an emergency situation. So the design of this valve, the design of this piston, gives no room to allow the pressure to counteract the seating of the valve. Once overpressure is relieved, the pilot valve is able to actuate again and close off the venting of the dome. The sense line is still receiving the pressure or still picking up the pressure from the system. It is now routed again through the tubing, through the pilot, and now it's able to feed the dome and load the dome, as we call it. And now force equals pressure times area takes over again, because this surface area is larger than this surface area, and although they're seeing the exact same pressures, because the surface area is larger, we have a larger force acting downward, therefore resealing the valve, resealing the system, ready to protect for the next overpressure scenario. So in conclusion, these valves are simply meant to protect your system and protect your lives. These valves are meant to be secluded at the top of your tank or your vessel or your system to protect your money and protect your life. These valves are not to be confused to be operational like butterfly valves or ball valves, where there's a constant actuation or constant on and off. These valves are to stay closed and are only used in emergency situations to relieve the system overpressure. Modulate opening opens proportionally, usually in liquids, opens proportionally to relieve what is needed when it is needed, usually and commonly with liquids, as we said. This is a great tool to not lose too much waste. Pop openings drive into full lift within 10% of the set pressure, and they relieve to a blowdown of 7% of your set pressure on the other side. So for instance, if you have a valve set at 100 psi, it has to open full lift by 110 psi, and it has to close by 93 psi. This is a pilot operated valve. In simple terms, the not so smart brother and the smart brother. The smart brother tells the not so smart brother what to do. And then the basic conventional relief valve. In short terms, the spring force is pressing down on a disc, which is sealing in your pressure here in the nozzle. Once this force is overcome by your system pressure, we have lift to relieve the overpressure of your system. And then once that system pressure is now under control, the valve reseats, and now your system is protected again. Thanks for joining us today. We hope that this has been beneficial and informational to you. And if it has been, please consider liking and sharing this video with your colleagues and your friends. And for more videos in the future, please consider subscribing to the channel. Thanks for joining us today, and be blessed.